Hey there, have you ever looked at a physics graph and felt like you were trying to read, I don't know, a secret language? Well, you're not alone. But today, we're gonna crack that code. In this quick explainer, we are turning those confusing lines into clear stories about how things move. Trust me, it's an essential skill, and by the end of this, you'll be interpreting them like a pro. For sure. I mean, really think about that for a second. How can one single simple line tell you if something is speeding up, slowing down, or just not moving at all? That's the real power of these graphs. They are just packed with information, and we're going to learn how to pull out every last bit of it. So, first things first. Before we can even touch these graphs, we have to get comfortable with the main character in our story today: acceleration. It is the key concept, the thing that describes any change in an object's motion. So, what is it really? Well, put simply, acceleration is just how quickly an object's velocity is changing. And you got to remember, velocity isn't just speed, it's speed and direction. That's why we call acceleration a vector. And that little formula you see, A equals dv over dt, that's just the physics shorthand for acceleration equals the change in velocity, dv, over the change in time, dt. That's it. Okay, so this whole concept really boils down to two main ideas. Positive acceleration, that just means you're speeding up. Negative acceleration, you're slowing down. Now, you might also hear this called deceleration, or in some really old textbooks, retardation. Don't worry, they all mean exactly the same thing. All right, now that we've got a good handle on acceleration, let's meet the tools we're going to use to actually see it in action. These are the three core graphs you absolutely have to know. Think of them as the ABCs of motion. Okay, this table right here, this is basically your Rosetta Stone for motion graphs. It translates everything. For each graph, the slope of the line tells you one thing, and the area under it tells you something else. So, for a position time graph, the slope is just your velocity. Now, for a velocity time graph, and this is the big one we're going to focus on, the slope is acceleration, and the area underneath is displacement, how far the object moved. And finally, for an acceleration time graph, that area tells you how much the velocity changed. Seriously, this table is the master key to unlocking all of these problems. So out of those three, the velocity time graph, or VT graph, is pretty much the star of the show. And you might be wondering why. Well, it's because it tells the most complete story all at once. It connects velocity, acceleration, and displacement. It's an absolute favorite on exams for a good reason. So, let's put this new knowledge to the test, right? Here's a classic problem. Imagine we're told a VT graph is just a straight line sloping downwards. What's the story here? What is the object actually doing? The first step to any physics problem is just to break it down. Don't get overwhelmed. We can pull three super simple facts from that one sentence. We know we're looking at a VT graph, we know the line is straight, and we know the slope is negative. Each one of those clues is a piece of the puzzle. And now, we just connect the dots. A straight line means a constant, unchanging slope. And on a VT graph, what does slope represent? Acceleration. So a straight line means we have constant acceleration. And since the slope is negative, that means the acceleration is negative. So what's our conclusion? The object is slowing down at a perfectly steady rate. See, you just read the story right off the graph. You're doing awesome, seriously. You've learned the language, you've practiced on a model problem, so now, let's see how this all works when the pressure's on. It's time to tackle a real question from a major exam. You can totally do this. Okay, here we go. This is a real question from the NEET 2022 exam. This is your chance to put what we've just learned into practice. I really want you to pause the explainer right here, look at the question on the next slide, and give it a shot yourself. Go on, try it out. All right, so the question is, the velocity time graph of a particle is a straight line, but this time it's parallel to the time axis. So imagine a flat horizontal line. What does that tell us about the particle's motion? Now, before we walk through the full solution, here's a little exam pro tip. If you ever see a horizontal line on a VT graph, your brain should immediately jump to two conclusions. 1, the velocity is constant, and 2, the acceleration is 0. It's one of those key shortcuts that'll save you a ton of time. So let's break down why that shortcut works. A flat horizontal line has no rise, right? It's not going up or down. So its slope is 0. And like we've been saying, on a velocity time graph, the slope is the acceleration. So if the slope of the line is 0, then the acceleration has to be 0. And if the acceleration is 0, what does that mean? It means the velocity isn't changing one bit. It's constant. And that's it. That's the answer. A simple visual cue, that horizontal line, tells you the entire story. And just like that, you've done it. You've gone from looking at these kind of confusing lines to reading the entire story of an object's journey. You've learned how to decode a really fundamental tool in physics. So the only question left is, what's next? What other concept, from forces to energy, are you ready to master?